Alright, in this video I'll be talking about how we add and subtract fractions that have unlike denominators. We call these rational expressions. And we've already discussed how to find least common multiples and least common denominators. Also how to rewrite fractions. We call it building fractions so that they have a common denominator. And so now we're ready to do some problems. Notice our steps here. It says to add, subtract fractions with unlike denominators, and we've already added fractions with like denominators. Number one, we're going to find the LCD, or the LCM of the denominators. We're going to rewrite each fraction with the LCD, and then we're going to add or subtract the numerators and leave the denominator the same and simplify if necessary. So let's go ahead and get started. So on the first one here, the LCD of 4 and 6 is going to be 12. Now remember, you can always start with the biggest number, in this case the 6, if you look at your denominators, and look at the multiples of 6 until you find one that's divisible by the other number. Notice 6 is not divisible by 4, but 12 is. 12 is going to be our LCD. 12 is a multiple of 4 and also 6. So we're going to rewrite our fractions so they have 12 as a denominator. You know what, let me grab a pen. So, excuse me, when we build fractions, I want to change 3/4 so it has a denominator of 12. What we did is we multiplied the denominator by 3, because 3 times 4 would give us 12. So we'll have to multiply the numerator by 3 in order to make it legal. This is actually 3 over 3 is 1. And by multiplying by 3 over 3, we don't change the value of the fraction. We just write it in a different form. Oops, so this will be 9 over 12. And then here I need to multiply by 2 to get 12. And so we'll also multiply the numerator by 2 and we get 2 twelfths. Now I want you to notice we started with 3/4. 9 twelfths is equal to 3/4. It's just not reduced. And this also reduces to 1/6. So what we have here is two fractions that are equivalent to the originals, but now we have a common denominator. That was the whole point. 9 minus 2, we get 7 twelfths. On number 2 here, let's see, our LCD, if you look at the multiples of 15, 15 is not divisible by 12. The next one would be 30. That's not divisible by 12. Neither is 45. Finally, you get to 60. 60 divided by 12, you get 5 there, so that does work. That's going to be our LCD. And so we can rewrite the fractions now so they have a denominator of 60. So notice to get 12 to become 60, you're going to have to multiply by, well, if you do 60 divide 12, you find that it's 5. 5 times 12 is 60. So we'll multiply the numerator by 5, and we get 25. And then here our denominator is 15. I need it to be 60, so I'm going to have to multiply by 4. Again, 60 divided 15 does give you that 4 if you don't know that. And notice the numerator, 8 times 4, we're going to get 32. So now we have 57 over 60. Just add your numerators. Let's move on to number 3. Now in this case, we only have algebraic factors in the denominator. The only one is x, and you would recall that we want to take the highest power of any algebraic factors we find. So our LCD here is x squared. So we're going to rewrite the fractions so that they have a denominator of x squared. Well, the second one already does. But here I need to multiply by x, so the numerator gets multiplied by x. And so we have 5x over x squared. And we have a common denominator, so we can subtract our numerators. We get 5x minus 3 over x squared. And we're done. Now you could break this into two fractions, but there's really no reason to do that. You would end up getting 5 over x minus 3 over x squared. But this is a perfectly good answer. There's no common factors in the numerator and denominator. We know we can't cancel this x with this one because this is a term. We can't cancel a term or part of a term. All right. If you haven't already been doing this, you might want to try the problems and then watch the video. So here our LCD, well, for 6 and 8, the LCD is going to be 24. We have an x factor. We take the highest power of x found. Well, there's only x to the first in both of these. Notice you don't multiply the two together. You take the highest power of x that you find. Well, the highest power is to the first. So we're going to rewrite these fractions so that they have a denominator of 24x. So you'll notice 4 times 6x would give us the 24x. We got to multiply the numerator by 4, we get 20. So 4 times 5 is 20 there. Over here, I got to multiply by 3 to get 24x. I'll have to do the same thing to the numerator, and we get 21. So we're going to get 41 over 24x. All right, let's move on to the next page. All right, so on number 5, if you were to try to factor this, there's nothing you can do. Same thing here. So we have to treat this x plus 3 as a single number. I call it an algebraic factor. It's just not multiplied by anything else. Same thing with x minus 4. And these are different, so the only thing we can do is multiply them together to get our LCD. Let's go back to what we did before. I would point out, oops, you can't see it. I would just point out back here we could have multiplied 4 times 6 and we'd get 24, and we could have used that as a denominator, but 12 is the smaller multiple of 4 and 6, so that's what we wanted to use, the smallest number we could work with to keep our math easier. But when we don't know what the numbers are, we don't have any choice but to multiply the two together, and that gives us our LCD. So we're going to rewrite these fractions so that they have this new denominator. So here I'm going to have to multiply by, let's see, I have the x plus 3, I need the x minus 4 factor. And I always like to put anything I'm multiplying in parentheses when it's a binomial or has more than one term. Of course, we're going to want to multiply the numerator by x minus 4 too. So we're going to have x minus 4 times x minus 2. Over here, we're going to have to multiply to get this new denominator, our LCD. I have to multiply by x plus 3. So we're going to multiply the numerator by x plus 3. So we get x plus 2 times x plus 3. Well, you can see I'm going to have to FOIL this numerator. I'm going to have to FOIL this one, or multiply it out, however you do. And then you'll add all of that together and you'll have this denominator. So I'm going to go ahead and FOIL this. Notice you're going to have an x squared. Your outer product is a minus 2x, and your inner product is a minus 4x. You're going to get a minus 6x. And negative 4 times negative 2 is going to be a positive 8. And then we're going to add to that what we get here. Well, x times x is x squared times 3. That's 3x. And in the inner product, we're going to have 2x, so that'll end up being 5x. And 2 times 3 is 6. Now, I'm taking a little shortcut here, but you should be able to FOIL that out and end up with what we have here. And I'm going to do a little trick here. I'm just going to put LCD. And in my final answer, I'll change that, but I want to simplify what I have in the numerator here. I have a 1x squared and a 1x squared, which is 2x squared. A negative 6x and a 5x is a minus 1x, or minus x. And 6 and 8, or 8 and 6, is 14. My denominator is x plus 3 times x minus 4. Now, I just want to say that normally, we certainly want to look at this numerator, and you can try factoring it, but you're going to have to find two numbers that multiply to 28. This is using the AC method, and add up to negative 1, and nothing's going to work, so this just doesn't factor, and so we're done at this point. But you should at least consider that. If it did factor, it's possible we could cancel a common factor. All right, let's move on to number 6. Now, I hope the first thing you see here is that both of these denominators have a GCF. Here it's 4, so it'll be 4 times y plus 2. And here you're going to have 5 times y plus 2. So the LCD of 4 and 5 is 20. And then we also need to include the algebraic factor that we have there, y plus 2. And so that's going to be our denominator, 20 times y plus 2. And so let's see. We need to multiply by 5 here to get the 20 that we need. So we'll multiply the numerator by 5. So we get 5 times y minus 2. Over here, on the second fraction, I need a 20. I've got the y plus 2 factor, so I'm going to have to multiply by 4. And so I'll multiply the numerator by 4. And so this, I'm going to put the 4 first. It'll be 4 times y plus 6. That's supposed to be a y. So I'm going to go ahead and distribute here. Well, actually, let me just go ahead and rewrite this. 5 times y minus 2 minus 4 times y plus 6 all over our LCD. So you could have done this step and gone from here to here. You just have to be really careful. We're going to have 5y minus 10. I'm just distributing here. And now I need to distribute the negative 4. It'll be minus 4y, and negative 4 times 6 minus 24 over the LCD. 5y minus 4y is y. Negative 10 minus 24 is negative 34. And don't forget to write out the LCD. It's 20 times y plus 2. Now you might be tempted to maybe cancel the 20 with the 34 or these y's, but you've got two terms here, and we've learned that you can't cancel terms, and so this is simplified. All right, let's move on to number 7. So first of all, I would hope that you notice that this denominator is a trinomial. Looks like we could factor this one. We know it's going to be x times x. It gives us the x squared, and since this is a 1x squared, we can look for two numbers that multiply to negative 20 and add to negative 1. Well, 4 times 5 is what's going to work. One of them needs to be negative, so when we multiply we get a negative. Since they add to a negative, make the bigger number negative. Notice 4 times negative 5 is negative 20, and 4 plus negative 5 is negative 1. So we'll put in our plus 4 and our minus 5. And so we're just factoring this bottom. I'm going to replace it with what I have here. So you can see in our denominator we have these two factors, and in this other denominator we just repeat this one. So we're going to write each algebraic factor we found to the highest power we found. Well, they were both to the first power. So this is our LCD, x plus 4 times x minus 5. Now notice in this problem we don't need to do anything. It already has that denominator. But over here, in order to get to the denominator here, I need to multiply this x minus 5 by x plus 4. So I'll have to do that to the numerator. You get 2 times x plus 4. Now I want to mention something here because this is a mistake sometimes students make. They'll get to this point. I mean, the whole point of what we've done up to this point is to get a common denominator. That way we can add our numerators. Sometimes students will get here and like they'll cancel here. But see, if you do that, you're back to where you started. The whole point of getting here is getting a common denominator. So once we do, we're going to go ahead and add our numerators. We'll get x plus 2x plus 8, I'm just distributing here, over our LCD. So we're going to get 3x plus 8 over x plus 4 times x minus 5. All right, number 8. Hopefully you notice the difference of squares here. This is y minus 2 times y plus 2. And so if you look at all our denominators, you only see those two factors, y minus 2 and y plus 2. They're all to the first power. We don't have like a 2 here. And so that is our LCD. So you can see this one won't need to change, but here we're going to have to multiply by y plus 2. So y plus 2 over y plus 2. Here we're going to need to multiply by y minus 2. So we'll do the same thing to the numerator. So here, remember, our goal is to get this common denominator, y minus 2 times y plus 2. So here we're going to have 5 times y plus 2. Here we're going to have 2 times y minus 2, just multiplying these together. Notice I'm not messing with the subtraction here. This is a positive 2 times what's there. And this last one, remember, that one doesn't change. We already have that denominator. So we're going to have 5y plus 2, 5 times the quantity y plus 2, minus 2 times the quantity y minus 2, plus y plus 3, and that's all over our LCD. Well, we've got some simplifying to do. We're going to have 5y plus 10, just distribute here. Here you're going to multiply negative 2 times each of those. You'll get a minus 2y plus 4 plus y plus 3. I'll still write it over the LCD. And now let's simplify this. You have 5y minus 2y is 3y, plus 1y makes 4y. 10 plus 4 is 14, plus 3 is 17. Again, don't write LCD. You want to write y minus 2 times y plus 2. All right, so that's number 8. Let's look at number 10. All right, definitely want to factor these denominators, and I'm just going to go ahead and do it to save some time here. I will assume that you can factor these using the AC method or some method. It's going to be x minus 2 times x minus 4. Notice these multiply to 8 and add to negative 6. And here you're going to get x minus 4 times x plus 3. So your LCD is going to include all the factors down here that we found. It'll be x minus 2, x minus 4, and x plus 3. So we need to rewrite our fractions so that they have this new denominator. So you'll notice here we're missing the x plus 3 factor. So you're going to have to multiply the numerator by x plus 3. It'll be 5x times x plus 3. Over here we're missing the x minus 2 factor. So we'll multiply the numerator by x minus 2. So multiplying these, you get that new denominator, and we're going to have minus 3x times x minus 2. All right, let me move this camera a little bit. So we're going to get 5x squared plus 15x. Now be careful here, you could write this minus this, but we're going to end up distributing negative 3x times each of these terms. We'll get a minus 3x squared and a plus 6x. That's all over my LCD. 5x squared minus 3x squared is 2x squared. 15 and 6, that'll be plus 21x. And that's over x minus 2 times x minus 4 times x plus 3. $15x plus 6x. I think that looks good. You could actually factor out an x if you wanted to. But you can see it's not going to make a difference. Alright, that's going to be it for this video.